Problem 9 asks you to show how to construct a circle into an approximate rectangle and give the dimensions. Now, I'm just going to refer you back to the video we did previously. This is the same board I did that video on. And we just slice up the circle, stack the slices, and we get something very close to a rectangle. If we make the slices thin, the thinner we make the slices, the closer this is going to be to a rectangle. And the dimensions of the rectangle are going to be half the diameter in this direction, because each slice is half the diameter from here to here. There's half the diameter. And half the circumference this way, because these segments on the outside are alternating. Okay, we got one here, then we got one on this side, one here, one on this side, one here, one on this side. These segments here that make up the circumference add up to a length that's very close to the circumference, and so that this side of the rectangle is about half the circumference. So you should understand that. Also, draw your attention to a couple of other things. Here we've reconstructed a trapezoid. We've broken it apart and rebuild it into a parallelogram, and the parallelogram then into a rectangle. You want to review that video if you don't remember how that works. We walked around a circle, and I walked around a circle. Got about 4 feet for the diameter, and just putting one foot in front of the other, and about 13 feet for the circumference. The circumference divided by the diameter then was about 13/4, or 3.25. And that's the ratio that I observed for the ratio circumference to diameter. Of course, my feet aren't really consistent measures. I don't put them down exactly the same way every time. So this probably is not equal to the ideal ratio. Well, the ideal ratio of circumference to diameter is pi. Okay? And that's what we got here. Pi can be taken out to as many significant figures as you can figure. You can look it up to 1,000,000 significant figures if you want. It's known to billions of significant figures, maybe even into the trillions. And there's no end to how far we can calculate it, and we know that our calculations are going to be correct if the computer doesn't malfunction. But pi is approximately 3.1416. Everybody should know that, and everybody should know that that's about 3.14 as well. And that is the ratio of circumference to diameter. So if you know the circumference, you can divide by pi and get the diameter. If you know the diameter, you can multiply pi and get the circumference. And if you need the radius, well, find the diameter and divide it by 2. Okay, just straightforward little things that you need to know and you need to remember. And then here we've calculated the area of the circle. This is how we get the area is pi r squared from what we have here. It's a very straightforward conclusion that we draw from this picture. So those are some pictures that you need in order to understand a lot of the problems that you might encounter.